Allora, grazie mille a Ubi, grazie a tutti per questo momento così goliardico. Riprendiamo con i talk del pomeriggio e proprio in merito alle community che animano questo palco e animano le attività dei vari eventi legati alla cybersecurity, vi propongo un battesimo di fuoco perché è la prima volta che sale sul palco Edoardo Dusi, al quale chiedo di fare un applauso. Un battesimo di fuoco nella nostra community, con un talk When Dependabot is not enough, protecting our software supply chain. Ci parlerà appunto di supply chain, della sua importanza per il codice e delle dipendenze. Cioè, cosa succede in GitHub quando vengono usate delle librerie e quindi il tool Dependabot gestisce automaticamente le criticità di queste dipendenze. E grazie a questo talk capiremo come funziona ed esploreremo anche possibili alternative. Un grande applauso per il nostro speaker.
Grazie. Il talk è in inglese, vero? Sì. Come voglio?
Like you want.
Ok. I do it in English so my friend can understand it. Okay?
Quante persone in inglese lo vogliono?
English or Italian? English? Italian? English one. Okay. So thank you very much to the organizers. I'm new in this. This is not my cup of tea. I'm a developer, okay? So I'm a developer relations engineer, so worse than a developer. I work for Sparfabric. We are a consultancy firm. We do custom development, cloud development. So I don't know how many developers are here, but this talk is precisely for developers. If you are a developer, you need to know this. If you are not a developer, maybe you have friends who are developers. So this is pretty important, okay? So this is an important concept because today I want to talk to you about the crucial aspects of today's security, which is the supply chain security, okay? In order to understand why Dependabot is an important tool and dependencies are a crucial part of our supply chain, we need to first understand what's the supply chain, because I think it's a concept that's not so easy to grasp, okay, for some of us. This is a definition that I could give you. The software supply chain refers to the end-to-end process of creating, delivering, and maintaining software applications. So if you are a developer and you already are familiar with this concept, maybe you know that. But if this is new to you, I thought I maybe can give you a way to better understand this concept using a similarity to the supply chain of an industry that we already know, of a physical good that we already know very well, which is the supply chain of a pizza. Okay, so let's start with that. If you want to make a pizza, you need ingredients. You need the recipe, you need to read the recipe, and you need to gather ingredients from different sources, right? So you need to turn to distributors. So in distributors, there are many makers of goods, many farmers that send their goods. And a distributor collects all these goods from many sources. So you turn to distributors to fetch the ingredients that you need to make a pizza. And all this process is certified. If you think of this process, of the physical process of having goods delivered through a distributor, you may figure the threats that there are in this process, because goods can be compromised, packages can be compromised, the supply to trucks can be compromised, the delivery for the delivery company can be compromised. It's easy to understand it because someone can physically sneak in the distributor and change things, okay? So this whole process can be compromised. So we need a marker to certify that the entire process is safe, because we need to trust that. So we need a marker like this, like the Conformité Européenne. But also the marker can be compromised if you see the China export marker, okay? So we need to trust this process, and we need something that can give us the trust. And you see, we have many farmers, many different farmers that create goods that we use as ingredients for our product. So the entire supply chain of the ingredients of our pizza is pretty much this one. So you see, if you picture what's the process of having something delivered to you when you want to make a pizza, you see the many threads that you can have here. So when you are a pizza maker, I don't know how to translate pizzaiolo, but pizza chef, okay, you gather all the ingredients from the distributors, you check your recipe, you check the bill that you have when you receive your goods, and you check that everything is in line with what you ordered. So you need to make sure that the ingredient that you ordered is the same one that you had in your receipt and that you have in your bill. And also you trust that when you receive something, this something has already been checked. And all this process is secure. You are trusting this process. Then there are two next steps, so three next steps, because also the environment where you're cooking the pizza must be safe, and also the packaging needs to be safe. So when you order a pizza, when you eat a slice of this pizza, you are in fact trusting a long chain of steps from the making of the initial ingredients to the delivery of the ingredients to the distributors, then the cooking of the pizza, and then the final delivery to you. You can also go to a restaurant and take your pizza, but you have many different ways to take your pizza home, and then you eat it. So you are trusting everything, okay? But you are not only trusting people, you are trusting a process that's being certified, marked as trustable. So we need something similar to this, which I think it's pretty much easy to picture in software. And we got to this in the last years with frameworks like this one. This is a picture from the Salsa framework, which is not a dance. Salsa, it stands for security levels for software artifacts. Okay, it's a specifications for having levels of security for your vendors for when you upload your artifact. Okay, for trusting the build process and the deploying process of an artifact. So it's a framework that you can use. And you see here in this picture the process of creating and distributing a software. So I am a web developer. When I create an application and I deploy an application, for example, a website, a simple website, I am in fact going through all this process because I'm starting developer projects from my local machine. So I have my source code and I have my source control management. Then I need to build my project, and the building process involves also many dependencies. We will concentrate on this later. Then I have to pack my project, okay, because I need to get an artifact that the consumer can then fetch, okay. And we have many threads on this. By the way, the Salsa specification, along with many other tools, are being made and made possible by the Open Source Security Foundation, the OpenSSF. Just out of curiosity, how many of you know the OpenSSF? Very few. Okay, I guess that. I'm part of the DevRel team in OpenSSF, and we try to communicate and to educate people around the importance of open source security, because open source today is the vast majority of code bases that we have around, okay? So ensuring that these code bases are secure is crucial, and we'll see why. So there are key components in our development process, okay? We start from development, then the build, the test, deployment, distribution, you know that, okay? And then the steps of having to update and maintain an application. Why this software supply chain? Now that you know, or at least I think you know what's the software supply chain, why is this so important? You see this slide, this is from Sonatype, and this pictures the growth of attacks. Since 2019, you see more than 700% of attacks year over year on the supply chain. And that's because two main reasons. Because open source won, basically, we have the majority of code bases are open source now. And this model, this open source model, was built around having many dependencies, many libraries, okay? And also because we have new kinds of open source attacks, of supply chain attacks, like we have typo squatting, we have dependency confusion, we have malicious code injection. We have new attacks on the supply chain. And also, you see the costs that these attacks have. We have this 46 billion estimated costs on the supply chain attacks for last year. And we will reach more than 80 billion in 2026. So for the global economy, this is a big deal, right? This is maybe the biggest case in the history of cybersecurity attacks. This is what sparked the interest into supply chain security. This happened in 2020. This company is called SolarWinds. They are an IT company based in the US. They have this product called Orion, okay? And Orion is a product for network management. I don't care. It's for network monitoring. And this product, Orion, was compromised, okay? It contained a malware. Many customers of SolarWinds received the update containing the malware as a regular security update, trusted because it was signed by SolarWinds. So and I'm talking about big enterprises like Microsoft, like Apple, and also security agencies like the Pentagon, like nuclear security, homeland security. So this was a big deal. And they all received the malware, which was undetected for months. And then they discovered that the build process, so this step, was compromised in SolarWinds. And this was such a big deal that the White House had an auction with the president of SolarWinds, the president of Microsoft, to talk about this project, this thing. The year after, we had Log4Shell. You may already have heard about this. It was a bug, a vulnerability in the Log4j library for Java. This is a tiny library for logging in Java applications, and many Java applications were relying and are still relying on a vulnerable version of Log4j. And this is Log4Shell. Using Log4Shell, an attacker could remotely execute code to servers. So all of these reasons together led government to work on cybersecurity laws. So, we had the National Cybersecurity Strategy in the US last year, and now we have the Cyber Resilience Act, the CRA, in Europe. So the idea behind these laws is to create the equivalent of the CE marks that we have for digital goods or for electronic, for the CE mark that we have for the physical goods, translated to the digital goods, okay? So similar to this one. But still, after the politics started to pay attention to this kind of attacks, still, a couple of months ago, we had this massive attack, the XZ outbreak. You may have heard of it. One of the most dangerous attacks on the Linux supply chain. And we were lucky, basically, because this was mitigated thanks to a random developer that discovered that his applications were behaving slowly, randomly slowing, and he decided to investigate and found out that a library included by his code was causing this delay. And so we were lucky. But the question remains, how many backdoors remain undetected? If we got this one by a chance, how many are undetected? So we need to picture the risks on the supply, or the software supply chain. Back to this picture, on many steps that we have for the supply chain, an attacker, there are many attack vectors. An attacker can submit an authorized change to our repo. So we can use a compromised source repo. When we are building our app, if we trust the source repo, but the source repo has been compromised, we can build from a compromised source repo and build from a modified source. An attacker can compromise the build process. And we can use a compromised dependency. Today, when we develop an application, we use many third-party dependencies, right? And one of them can be compromised. We can then upload a modified package. If we are not sure that our packing system is safe, we can build a modified harmless package. And the package repo, we upload the package to a registry, and that registry can be compromised. And so a consumer can use a compromised package. So this is all the potential threats that we have, thanks to this list by Salsa. I will also add, if the dependency itself becomes unavailable, then we are not able to build our application anymore. So for example, if we need to patch, to deliver a patch quickly, and we cannot find a dependency, our entire app, we cannot build it. And so we cannot ship our updates to customers. For having a more concrete idea of how big this is, let's have a look at the JavaScript supply chain, for example, which I know pretty well. I found this quote from this blog post. So installing an average NPM package introduces an implicit trust on 79 third-party packages and 39 maintainers. So when you are writing a JavaScript application and you include a dependency in your package JSON dependencies, you, on average, are downloading 79 third-party packages, and you are trusting all of them, plus the 39 maintainers on average behind them. So this is a pretty large attack surface, right? And NPM is a massive ecosystem. We have these statistics from Sonatype last year, 2.5 million total projects, 37 million projects versions, and it's growing 27% year over year, 80% year over year, the download rate is growing. So this is massive. And if you look also at the PHP supply chain, you see now, today, a modern PHP application is not PHP from scratch or just a framework, but it depends on many other ecosystems. Like in a modern PHP applications, you have JavaScript libraries, you have maybe Python, you have Go, you have many other things. So you need to trust all these ecosystems. And then your PHP app needs to run on a server, so you are also trusting the operating system. You are trusting your Linux distribution, you are trusting the package manager for the distribution, or Android if you're deploying on mobile. So you're trusting many other things. Then you need to test, you need to deploy, you need to run static analysis, you need to deploy on your cloud platform, you have your local environment. So you need to trust every step on this. And you see how many attack vectors there are, referring to the Salsa specification behind. And also Composer is a pretty big ecosystem. We have like 300K packages and 2.5 million revisions, and it's growing too. So also Composer is an ecosystem that's growing, okay? So now we see that the supply chain is pretty important. And it's massive. Virtually any code base in the world, data from a GitHub survey, more than 90% of all the code bases in the world include at least an open source dependency. So open source is pretty much everywhere. And so now we should have an idea of how important this is. So this can be attacked, and we can include a vulnerability in our code base. Okay, so we need to understand what's a vulnerability. And I found this definition on the website of Common Vulnerabilities and Exposure Program. A weakness, this is a vulnerability, a weakness in the computational logic, for example in code, found in software and hardware components that, when exploited, results in a negative impact to confidentiality, integrity, or availability. So it's a pretty large definition. And I will summarize it in a vulnerability is anything a threat actor can exploit to perform malicious activity. So everything. It's not only the bugs that you are injecting in your code, but it's also what you are depending on. So dependencies are crucial. And you should know your dependencies. This is really important. There are many tools, and again, I'll invite you to look at the OpenSSF websites and many other websites that lists the ways that you have to know every dependency that you are including, that you are depending on, and their vulnerabilities. And the tool I want to talk to you about, and finally we are on the main topic of this talk, is Dependabot. Dependabot is a tool which was developed independently, but then acquired by GitHub. So today, Dependabot is a GitHub project. And it was developed with security in mind to enhance security and the best practices in development. And it helps developers to keep their software up to date. It's fully integrated into GitHub. And today, the core is open source. It's news we had in last weeks. Today, the core is MIT licensed. And this tool helps you to have an understanding of all the dependencies that you have on your application and the vulnerabilities that they have. This is the important part. With Dependabot, you can automatically have a vision of all the dependencies, of all the vulnerabilities that you have in the dependencies. How does this work? This, if you activate it on your GitHub repo, by the way, you can also integrate it in any other source code management system you have, but it's pretty easy to activate it on GitHub. If you have a repo on GitHub, just activate it. Dependabot scans your repository for outdated or insecure dependencies, and it can open a pull request for you for updating the dependency. It can be configured to run specified intervals, and it provides you with alerts, automated alerts for vulnerabilities found in your dependencies. It can support private and public repo. And this is a short video of the interface of Dependabot. You see the lists of alerts. You can click on an alert. You see the details of this alert, and you can dismiss the alert. So you see, you have a pretty big list. And of course, you need to focus on the vulnerabilities that can be exploited for you. But Dependabot gives you an overall vision of all the vulnerabilities that you have. And this is another one when you can tell Dependabot to open a pull request for you. In this example, Lodash was vulnerable. The version that this project included was vulnerable. And Dependabot is able to just update Lodash to a newer version just by opening a pull request for you. So you may think, OK, Dependabot scans my code for dependencies, and it alerts me for vulnerabilities. Where is vulnerability information coming from for Dependabot? So GitHub has this database, the GitHub Advisory Database. This is, you can find it on this link, github.com/advisories. And this is probably the largest vulnerability database available online. And also what's important is that it's created by a team, a dedicated team. And it's also supported by community contribution. You see, it's also an aggregator of different ecosystems, different vulnerabilities from various ecosystems. Security advisories are published in this format, the open source vulnerability format. We'll see more about that later. And one of the most prominent databases where the GitHub advisory fetch information is the National Vulnerability Database, the NVD, which is powered by the NIST, which is a government institution. And these vulnerabilities on this database is published using another format, which is the Security Content Automation Protocol. And all vulnerabilities here are assigned an ID. The ID is the Common Vulnerability and Exposures, the CVE. And any vulnerability is also assigned a score, CVSS, which is a score for the urgency, for the danger of a single vulnerability. I don't want to take anything for granted, so what's the CVE identifier? I know you maybe know it very well, but just to make sure, this is an ID to uniquely identify a vulnerability. Okay? It was launched in 1999. Through a CVE identification, you can relate a vulnerability to a specific version of a software, of a library. Okay? So you have a consistent referencing. Now, are there any other databases out there? Because you see, we have the GitHub Advisory Database, but currently there are other databases, the most important of which is the open source vulnerability DB. This is, you can find this on osv.dev. It is also an aggregator of other databases of vulnerabilities, and it is also curated. It was launched in 2004. This is the home page. I have some more information. It is an open approach, so this is all open source. And it introduces the OSV schema that we saw before that GitHub Advisory is also using. This is a data format. In this data format, which is a JSON format, you find all the information on the vulnerability and a mapping to a precise version of the software. And this is still was created by members of the OpenSSF. This database is also supported by the OpenSSF. And it's an aggregator of other vulnerability databases, like also the GitHub Advisory, because the format is the same, but also others. You can also scan your vulnerability using different tools. You don't have to use Dependabot. You can also use other things. For example, you can use the OSV scanner, which was developed by Google. It is a Go scanner. It is a Go project. It does pretty much the same things. Scans your source code, finds your dependencies, and then collects vulnerability information from the OSV database. So it's basically a front end for OSV database. And it also, and this is important, it analyzes all your transitive dependencies, so the dependencies of the dependencies that you installed. And also the manifest, the SBOMs, and commit hashes. SBOMs, by the way, the SBOM is a format, it's the software bill of materials, so it's the format of, it's the list of all the ingredients that you have on your application. And also in OpenSSF, you find many tools and many working groups discussing SBOMs and related software. And the OSV scanner is integrated in this other tool, which I don't have the time to talk about, but it's another tool by OpenSSF, which is Scorecard, which basically gives you a rating, a score for the best practices that you're using on your repo. This is the second option that I will give you. It's Renovate, or maybe you know it by Renovate-Bot. This is a multi-platform dependency update tool. It's basically a Dependabot competitor. It does the same things. It's customizable via a config file, a YAML file. It supports many different source code management, so you can integrate it on GitHub. You find many tutorials with GitLab. And it can be self-hosted. So for example, if you have GitLab self-hosted and you need to run a self-hosted tool, you can run Renovate because you can self-host Renovate. And it is open source, but the license is not MIT, it's AGPL. And the last one, it's Snyk open source. Snyk is a collection, it's a platform, it's a collection of tools. This tool is Snyk open source. Oh, by the way, Snyk is a member of OpenSSF. This tool, it's basically a vulnerability scanning tool. It's also static analysis. And it also scans for licensing issues. This maybe would be important for you. For example, if you're working for the public administration, for example, and you have licensing requirements. So with this tool, you can also check that the dependencies that you are integrating are compliant to the licensing requirements that you have. And it can be integrated in any step of the software development lifecycle. So with Snyk, you can integrate it on your command line when you start developing. You can run static analysis on your code. You can run automatically on the build, or also in your CI/CD pipelines. So it's pretty flexible. And also, this can automatically fix your vulnerabilities by opening a pull request, or also by suggesting you the changes that you need to apply to your code directly in your editor. So you can check this out. And lastly, I want to list some best practices that you can check when you're searching for a good vulnerability management tool. Okay? So what to look for in an open source security tool. Now that you know that open source security is really important, what you need to check, what you want to do, what you want to have on this tool. You want this tool to provide you a comprehensive view of all the packages that you are using and all the vulnerabilities that you have on your packages. So you need to answer to this question. Are you depending on a vulnerable component? This is really important. And also you want this tool to be automated. You don't want also the burden to having to run other tools. You want this all to be automated. If you have a developer team, you don't want to ask them to integrate another tool which they don't want to do. You want all this to be automated, like Dependabot. You check a checkbox, and then all the tools are run automatically. You also need easy integrations with your developer tools, whichever tools are you using, your workflows, your pipelines, so your developers should easily see the fixes and apply the fixes. You also want to have an up-to-date and enriched database beyond known CVEs. So you know that there are, for example, the NIST list of CVEs, but then now you know that there are also other databases which are curated by people, which enrich the CVEs with other information. For example, if this CVE is exploitable in a specific scenario. So you want your tool to depend on this kind of database. And the last one, you want a continuous monitoring of projects. So your source code, your code base, your application needs to monitor itself. So it needs to be able to monitor itself without your intervention and alert you when it finds a vulnerability, an alert, okay? Lastly, since I talked to you about OpenSSF, I want to also to tell you how you can contribute to OpenSSF, because we need contributions. We also need to spread the word, as you saw. And there are many ways to contribute to OpenSSF. By the way, OpenSSF, it's an open organization. It means that we are part of the Linux Foundation, and there are many members among us between big enterprises, but also smaller organizations. And you can join as a paying member. There are various ways to contribute financially to OpenSSF. But if you don't want to financially participate, you can also join the discussions. And these are some of the entry points that we have. I will go more in detail. You can follow this calendar. This is a calendar with all the public meetings that OpenSSF is holding. In OpenSSF, we have many working groups dedicated to specific topics. For example, we are talking about SBOMs, we are talking about vulnerability management, many other topics, okay? So we have a working group dedicated to each of these topics, and you can join the public meeting usually once per month, okay? If you don't want to talk, just join the meeting, put you in mute, and follow the discussion. It's valuable in itself. And also, you can join our Slack channel on slack.openssf.org. And here you can also find the many channels on which we are talking about different topics, right? The community is very welcoming, and I think it's pretty interesting to see what many people are discussing about regarding open source security. So you also be sure to follow us on social media. You find us on many different social media, and also we have a YouTube channel if you want to see our recorded video. So thank you very much. I'm Edoardo. Thank you. You can find me. No, please give me back my last slide, please. Yes, you can find me online with this handle pretty much everywhere. And you can find me also on Mastodon if you want to communicate with me. I'm at edo@continuousdelivery.social. And if you want, I also have my YouTube channel and a podcast in Italian. So if you want to follow some news related to the tech world, you can follow me on YouTube or Spotify. Now you can close this slide. Thank you.
Grazie Edoardo. Thank you very much.